Okay, thank you everybody. This is a video recording to walk people through how to do the distributed key generation process as part of the Athena testnet. If you're watching this video, the plan right now is you'll have been informed that you're going to come to a distributed key generation ceremony. You'll have been provided with what's called a cluster definition file. And that's basically a file that explains to the Charon client who to talk to and what are the terms of making a new cluster. So I have in front of me the README and the same repo that you had to check out for step 1. Step 2 in this case is done by the Obel core team. We will create the DKG configuration and give it to you along with the message you got to come to this ceremony. And then what we're going to do is we're going to do step 3, which is running the distributed key generation. At the moment, I have 3 of my core team with me on this call, and they're going to be running this alongside me. So this is the command you're going to need. Before you run it, you just want to make sure that you're checked out into the correct folder, which is Charon Distributed Validator Node. And if you do an LSLA, it'll show you hidden folders, which should include the .charon folder. And just to be sure, you can check what's in the .charon folder. You will need the Charon ENR private key, which is the private key generated in step 1. And you'll need the cluster definition.json, which you'll have downloaded from us, and you need to save to this appropriate folder. And that's where Charon is going to look for it. If you can't save it to that folder, you can change it to somewhere else, and you can override it with the path data there. But all that aside, it's now time for us to do the distributed key generation. So you copy in the command that's in step 3. And without further ado, I'm going to hit go. And it's now started. So it queries the boot node and starts to connect to peers. You should see this connect to hopefully all 3 peers. There's 1, there's 2. And now connected to 3 peers, and it's going to create the distributed key. And success. That's all there is to it. And if we now look in the folder that we have, we can see that we have the same private key, we have the same cluster definition file, but now we have more things. We have the cluster lock, we have the deposit data, and we have the validator keys folder. So briefly, just to explain this to people, the cluster lock is the config file you give to Charon run in stage 4. The deposit data.json, this is the info that you need to activate this validator on the network of your choice. So you would bring it to the launchpad and deposit 32 Ether along with the data in those files to activate them. And then the last folder is your validator keys folder. This is the folder that contains all of the private keys for your piece of the distributed validator. So if I look to see what's in it, you can see that there, in this one's 3 key stores, because we decided to create 3 distributed validators with the ceremony we had. It's super important before you finish this to take a copy of all of the .charon folder. So that includes the private key, the definition and cluster lock, the deposit data, and the validator keys. From here, the next step in the process is your team leader will upload the cluster lock and the deposit data to the Obel Typeform. That's what we need to verify that the DKG was done correctly and to activate these validators with 32 ETH. Your next step is to start your cluster and get it stood up and talking to other nodes. You can start that now by running Docker compose up and completing step 4. Or you can wait a couple of days and set up your machine and your dedicated hardware if you're doing this on a dev machine. Right now, you'll be told effectively, you'll be given a notice about activating these validators when the time comes. We'll give people usually 7 days from the point of uploading the deposit to us activating them, just to give you time to sync your node and make sure everything is connected before the validator comes online. That's pretty much it. Thank you very much.